Welcome to the webinar. We'll be starting shortly. Please stand by. Hello, I'm John Klobuchar with InEight, and I'd like to welcome you to our latest webinar in our Risk Planning and Scheduling series. Today's webinar is titled Machine Learning, Your Next Planning Game Changer. Our presenter today is Dr. Dan Patterson, who is Chief Design Officer at InEight. In his role, Dan focuses on expanding upon his vision of creating next-generation planning and scheduling software solutions for the construction industry. Dan is a certified project management professional by the Project Management Institute. If you have any questions as you watch today's webinar, please submit them in the question window, and Dan will do his best to answer a few of them toward the end of the program. Also, today's webinar is being recorded, and we'll be sending out a link to the video within the next week. Once again, we're glad you've joined us, and now let me introduce Dr. Dan Patterson, who will take it from here. Dan?
Well, John, thank you very much for the warm welcome. So I'm very excited to spend the next 30 to 40 minutes or so sharing with you all my thoughts on machine learning, and specifically machine learning as it pertains to planning and scheduling. And I think it's a very topical webinar, given that today it's hard to not pick up a newspaper or go to a news website and not stumble across something to do with either artificial intelligence or machine learning. So really my overarching objective in this webinar is to demystify this science, often described as a black box with regards to artificial intelligence, and really share with you how I genuinely believe it's actually going to improve the science of project management, and specifically planning and scheduling in the forthcoming years. So in terms of the kind of the agenda and the flow, I think it's probably worth starting with, well, where are we at today? What are the pain points that we're experiencing with planning and scheduling? And then really that's a good lead in as to, well, okay, how can this thing that we're calling artificial intelligence and machine learning, how can it actually help? And then from that, I think we're in a great position at InEight with regards to, we really have a 2-year head start already on actually adopting and embracing artificial intelligence and machine learning to the point where those technologies are actually embedded in our planning and scheduling solutions today. So, I'd like to share how we're implementing those today, and also touch on some of the lessons learned that we've encountered along this journey of really starting to change the way humans and computers interact. When I think about artificial intelligence and sort of break it down into very simple parts, I think, well, okay, pre-AI and machine learning, the interaction between a computer and a human was the human giving the computer information through the likes of a keyboard and a mouse. The computer then does a calculation, but really the interaction was primarily me, the domain expert, the planner, the scheduler, giving information into the computer. Now, with the advent of artificial intelligence, and this is where I get very, very excited about this technology, is the fact now that as I, the human, give the computer information, the computer in real time is actually acting as a guide, as an assistant. It's endorsing information that I'm giving it. It's potentially pushing back and warning me of errors or erroneous information that I may be entering into my plan. So it's starting now to be truly a two-way interaction between the human expert and now what is becoming the computer expert.
That's fascinating.
It is. It's very, very exciting. So Having said that, again, just to kind of start off with, well, why the need for this improvement for planning and scheduling? So when we look at the mechanism for planning out large capital expenditure projects, I find it quite interesting that really the technique hasn't fundamentally changed in the last 50 years. You know, we all use this technique called critical path method, or CPM. It's really the backbone to commercial scheduling tools such as Primavera and Microsoft Project. So the actual technique hasn't changed at all, and I believe the technique is fundamentally sound. Where I think we can improve is really in several areas. First of all, you know, the fact that in the early stages of either putting a bid together from a contractor perspective or from an owner perspective, if we're looking to embark on a project and we're looking at things like concept select, you know, the fact that the schedule, the time forecast that we put forward is very often divorced and separate from the cost estimating process, I find quite challenging. I think as we move forward, you know, the building of the time forecast and the building of the cost forecast, they're inherently linked, and so the software tools that we use to put forward those forecasts should actually be linked as well. I think one of the fundamental challenges that we've had to date with CPM scheduling is the fact that you know, I look at it as, I call it silo planning, whereby the planner or scheduler, they're sitting in front of a computer, they're expected to understand, you know, the scope of the project and all of the nuts and bolts that go into that plan. There's very limited collaboration and drawing from information and expertise from the field executioners, the discipline leads, the engineers, the people that actually know what it is and how to build what we're building. So if we can emulate that through computer expertise, if the computer can capture that expertise of those discipline leads, store it, and then regurgitate it in a way that's useful when either planner and putting forward my plan, that has to be advantageous. So, you know, again, I think the mathematical science of critical path method is fundamentally sound, but I think that there's a massive opportunity for improving the way in which those plans are built collaboratively, and if that collaboration again can be augmented through artificial intelligence, in other words, the computer making suggestions, that has to be a massive step forward. So talking of this artificial intelligence or AI concept, so just to give a little bit of background as to exactly, you know, really what is artificial intelligence or what is AI. On the screen here, there's several different definitions or descriptions. So the first one talks about a device that perceives its environment and takes actions that maximize its chances of successfully achieving its goals. I think that's interesting. I think probably more relevantly to project management, the second definition here, the ability for a computer to perform tasks that normally require human intelligence. That's absolutely spot on. Again, if the computer can start to make suggestions and understand context, understand the type of project, the complexity of project, common risks that have occurred on analogous projects in the past, then we're absolutely getting to the point where the computer is starting to emulate that human intelligence, that human expertise. McKinsey has a very simple definition, and I think it's absolutely fantastic. An AI algorithm is based on learning from the past. That's exactly what we're trying to do when it comes to capital project planning. We're trying to put forward a forecast to the best of our knowledge that we can achieve based on what we know from the past. And again, if the computer can help with not just capturing that past historical information, but if it can help with regurgitating it back to the planner when the planner is trying to put forward that forecast, then job well done. So machine learning is actually a subset of the science of artificial intelligence. So if artificial intelligence is the ability for the computer to emulate a human with regards to its thought process, machine learning is more akin to the computer learning from its mistakes and getting smarter over time, if that makes sense. So, you know, in very simple terms, it's the ability for the computer to self-adjust. So, you know, a computer may have an algorithm that it uses to perhaps make suggestions as to relevant durations. Well, if that algorithm is returning suggestions that aren't necessarily accurate, if the computer can learn from the fact that it's making not very accurate suggestions, if it can learn from that and adjust the way it makes its suggestions and adjust the way it goes and mines information, then it becomes self-adjusting, it's self-learning. That's the machine learning piece.
Is that the same thing as deep learning, or are those two different terms?
So actually, deep learning in itself is a subset of machine learning. Okay. Absolutely, yes. Yeah, and there's different technical approaches for machine learning. There's things such as neural networks, which involve, in fairly simplistic terms, it's looking at pattern recognition. And in order for the pattern recognition to be accurate, you have to train that neural network. So you can train it, the more historical projects you throw at it and look at the outputs, it can then adjust. And in fact, that's a good lead-in into a couple of slides. I'll touch on neural networks in a few minutes. So with regards to how does machine learning help us better plan, again, I think it's very, very simple. If I, the planner, can leverage historical project information without having to manually sift through old PDFs and analog drawings and schedules, if the computer can digitize that information and then classify that information in a way that it can then go off and mine it and come back with suggestions, then that's a massive step forward. Computers are very good at mining information very, very quickly. Humans are not very good at that. What humans are very good at, though, is understanding context. And so if artificial intelligence can cross that bridge and allow the computer to understand context, then you get the best of both worlds. You get contextual understanding by the computer and obviously the computing power that allows it to mine vast quantities of data very, very quickly. So with all of that, if the computer then can make these suggestions pertaining to maybe duration or even sequence of work, it doesn't just have to be limited to, hey, Dan, the planner, you've got the duration wrong, but what if the computer were even able to understand, well, you've got the sequence of work wrong, or perhaps the phasing of the work is not sufficient to uphold. So for example, if the procurement scope is being executed too late relative to construction, then procurement will execute as planned. Everything looks great, but it's going to have a knock-on effect on construction. So the root cause isn't actually construction, it's procurement. So it's that kind of insight that I think is very, very useful. This all drives what I call confidence of schedule. So again, I see this as the third dimension in planning and cost estimating. It's one thing to say our project is going to take so many months to complete and cost so many dollars. That's great, but what is our confidence level in achieving that time and that cost estimate? So bringing to the table this third dimension of confidence levels and reducing risk, I think is another massive step forward. And it's all tied to AI and the computer knowing, based on historical projects, okay, if you're saying this is an 18-month project, historically it takes 24 months, then we start to get an idea as to how confident we are, or conversely, how much risk is we have exposed on that project. So on the right-hand side, this sort of the schematic here is really trying to illustrate the fact that, yes, the computer makes suggestions and can critique what the human is building, but then the human then has the opportunity to adopt or push back on those suggestions, and it's that adoption and or rejection of suggestions from the computer that the computer picks up on to do its machine learning. So it's this continuous knowledge improvement cycle. So John, you were asking about machine learning and things like deep learning, and I alluded to this concept of a neural network. So just very, very quickly, this is a simple example of a neural network relating to CPM scheduling. So the concept is that, okay, the computer is being asked to go and mine, let's say, a historical database of Primavera schedules. And we're asking the computer to come back with analogous duration matches. So I'm building out my schedule and I'm wanting the computer to critique the durations that I'm assigning to those activities. So what it does, it goes up and it mines the information, but it has to come back with a match, where it uses the match to come back with those suggestions. Now, in the most simplistic case, you might say, well, okay, we're just going to match on description. So I'm working on an engineering task. Let's go and find all the tasks in the knowledge library that have the word engineering. Well, that's all very well, but what if in those historical projects, engineering wasn't called engineering, it was called design, or ENG. So we have to go above and beyond just using simple attribute matching such as description. So the way a neural network works is you actually define multiple attributes. So in our example here, we have description as the first attribute, but we also have phase of the work as a second attribute. And the third attribute is, do we have similar logic coming in and out of the activity? So what we then do is we weight each of those attributes. And to give you a real world example on the next slide here, on the left-hand side is an example where when the computer goes off and does its search, it's come back with an activity where the description matches. So, you know, the 0, 1 binary inputs on the left. So the match is a positive. However, the phase of that activity and the logic going in and out of that activity is completely different. So we get a fail on the phase and a fail on the logic. Now, because the weighting of description is relatively low, we get a 1 times 3 on the weighting, because it's a positive match on the description times the weighting gives us a total output of 3. Now, that's a relatively poor match. What does that mean in human terms? It means, okay, even though the descriptions match or they're similar, the chances are we've got the wrong activity because the activity in the knowledge library is at a different phase of the project and the logic's completely different. More interestingly, on the right-hand side, the example says, okay, even if the description doesn't match and we get a 0 return, if the phasing of that activity in the knowledge library is very similar to the phase in which we're planning the current activity, and the logic is similar, we get 2 positives. Those positives multiplied by the weightings give us a 7, which is a much higher match score than the 3 on just description. So that's, in simple terms, how a neural network works. And what's really powerful about a neural net is over time, if the planner adopts the scenario on the right-hand side, it will continue to add emphasis and weighting to the attributes that caused that positive match. Okay, so it's those weightings that get automatically adjusted. That's the learning piece of artificial intelligence. Okay, so that's a little bit of theory behind AI and machine learning. Let's relate that back now to the real world. So as I mentioned, you know, for the last 2 years now at InEight, we've absolutely embraced artificial intelligence and machine learning. It is absolutely embedded in our planning, scheduling, and estimating solutions. So the workflow on the screen here, what this pertains to is the fact that really in an AI-driven or a knowledge-driven planning environment, you really have 2 roles. You have what we call a knowledge administrator and you have the planner. So the knowledge administrator is typically responsible for, first of all, capturing historical information. So that may be pulling in those historical schedules, those cost estimates, those risk registers, even things such as rudimentary as historical productivity rate tables. Now, all of that information data capture is relatively easy. Where it becomes a little bit more challenging is with regards to classifying that data and converting that data into knowledge. So we do that through what we call knowledge tags. So John, think of knowledge tags as attributes. So an attribute may be a geographical location, it could be project type, it could be a market condition. So those 3 attributes then, if we have 100 historical projects in our knowledge library, the idea is that the knowledge administrator will, I call it decorating, but they will flag or tag each of those projects with different values for project type and geographical location and market conditions. The reason why that's so important then is flipping over to the planning side or the planner side, when the planner is building out his or her CPM schedule, the first thing they actually will do, they'll tell the computer context. So they'll tell the computer, hey, I'm building a project of type X and it's of complexity Y in a geographical location and it's going to take so many years. So based on those contextual attributes, the computer straight out of the gate knows to a degree which projects to go and focus on in the knowledge library. Okay, so if I'm working on a vertical build project, don't go and bring back a whole bunch of linear construction type projects. So it's those knowledge tags that the computer uses for that initial understanding of context. Does that make sense?
What I'm thinking is it seems like a massive time saver and keeping people from doing a lot of menial tasks and all this research. You have now our AI to help you complete all this tagging that you would normally need someone at a computer working all day on it.
Absolutely, and the value of the tagging is, again, it's at runtime when we're building out our plan, it's then that gives the computer the hooks that it needs to understand context. Going back to that neural network example, it knows which attributes to look at when going off and mining and bringing back the suggestions.
Mm-hmm.
What that then allows the planner to do, as you can see on the right-hand side, it's really we've broken out planning into a three-step process. And again, I think this is a big step forward. In previous times, planning was planning. You'd use a CPM tool. But I think what we're doing now is much more effective, because what we're saying is, well, in the early stages of a project, you probably don't know, or don't even need, you don't know the information that's required to build out a very detailed CPM schedule. So things like multiple calendars and very detailed quantity estimates, things like that. You're probably going to start at the concept phase, and you're really building a top-down estimate or a top-down forecast. It can be as simplistic as just timelines in sequence. So in InEight Basis today, that's the name of our planning and scheduling solution within InEight. The concept is that doing that top-down planning, you tell the computer the context, the computer comes back and says, okay, these are those top level, not just WBSs, those work breakdown structures, the framework, but it also comes back with durations for each of those framework elements, and we call those planning packages. So that then becomes essentially your early stage target schedule. Now, the second step is when we get into the detailed CPM scheduling. So this is when we build out the work that is required to achieve that top-down forecast, which is really a deliverable-based forecast. So that's your activities, your logic, your calendars, your constraints, all of the building blocks that you would typically use in a CPM schedule. Again, where I think we're really pushing the boundaries now is, though, to take that to the third level with regards to what we call field execution planning. So the concept here is that in the field during execution, using a 5,000 activity Primavera schedule with incredibly complicated logic is not going to work when you're out in the field, when you're trying to do maybe just a 2 to 3 week look ahead. So what we're introducing now is the concept of what we call short interval planning, where you can use that very detailed CPM schedule as a framework, but as, for example, a foreman, I'm only interested in the next 2 weeks window.
Right.
Well, the tool will bring me back 2 weeks worth of CPM activities from my CPM schedule, but then I have the flexibility to define daily steps and assign crews to those steps. I can then start to bring into account, well, how many quantities are required to satisfy this work. I can then start to look at productivity rates. It's much more focused and oriented around field execution than CPM scheduling. But the beauty of all of this, it's all linked from that top-down forecasting to the bottoms-up CPM scheduling to the daily or shift-based short interval planning. So let's walk through some of those steps in the product itself. So we talked about on the left-hand side of the previous slide, this concept of data capture. So in Basis today, John, you can actually pull from multiple data sources, whether it's Primavera P6, Microsoft Project, even just flat files such as Excel or CSV files. So in the knowledge library, you can store schedule information, you can store cost estimate information, productivity rates, and most recently, you can also now store historical project risk registers. So a risk register is really an encapsulation of a list of either positive or negative risks that occurred on previous projects. And the reason why that's now becoming so valuable is the ability now to generate a risk-adjusted forecast. So I, as the planner, build my schedule. It says, okay, the project's going to take 24 months. Okay, but the risk-adjusted version of that schedule is actually showing 28 months. So now the tool is actually able to take into account potential risk and uncertainty on the project as well. So step 2 is knowledge classification. And I alluded to this concept of knowledge tags. And John, maybe this is a better visualization on the right-hand side here. We've got an example where we've got business unit complexity and geographical location. So these tags, as I mentioned, actually help the computer understand context. So if I'm working on an infrastructure project and it's in North America, the computer's going to use those tag values to go off and mine the relevant information. Now, that's very useful, but what is even more useful with regards to knowledge tags, you see the little sliders on the window here. What that allows the computer to do is automatically normalize the data that it throws over the fence to the planner. So, for example, on the location tag here, we've got North America and Asia Pac. You can see there the productivity rates, the factors are slightly different. So if the information in our knowledge library is pertaining to Asia Pac, but we're working on a North America project, it uses those factors to automatically normalize when it makes the suggestion. Very, very powerful. It's really an automatic means of cleansing the data in the knowledge library. And then thirdly and finally, with regards to knowledge management, this is this goes back to the weighting of the attributes. So again, I demonstrated a conceptual example of a neural network where we have multiple attributes. So the attributes on the right-hand side here, these are examples of some of the attributes that the basis, what we call the inference engine, the brain, goes off and uses to try and make its match. So yes, of course, it's going to try and match on description. But if we go down to a few levels down, we've got things like parent deliverable. What that is, John, it's saying, okay, even if the description of my activity doesn't match, in a CPM schedule, you have a hierarchy of stuff through a WBS structure. It's probably more likely that that WBS hierarchy, that path of stuff, is going to be a stronger indicator that I've got the right activity than just the description of the activity itself. So the AI engine, the inference engine, is smart enough to even look at where the activities sit in the hierarchy of the project. Well, that's pretty cool, because then you don't have to worry about description matching. It's going to start doing analogies based on things like your WBS structures. Even things towards the bottom there, such as duration and phase. So even if the description is a very good match, and I've got a very similar WBS structure, if the activity I'm working on is a 20-day activity and the computer has found an activity that it thinks is analogous in the knowledge library, which is 200 days, chances are it's two completely different types of scope. It's not going to pull that back as a return. So does that help a little bit?
It does,
with regards to sort of the setup and the conditioning of the information to convert it into knowledge? Yes. All right, so let's now focus on, I think, probably the important stuff, which is, okay, as a planner, how does this all work? So step one is to tell the computer the context of the project. So in the three screenshots here in the top left, this is where we define those knowledge tags. We're telling the computer which business unit this project pertains to, relative complexity relative to prior projects, geographical location, and market condition. And then based on those, it will come back with a suggested work breakdown structure. And what's really, really cool about this is when it comes back with that structure, it may mine a project from the knowledge library that was, again, let's say 20,000 activities down to level 10. Well, at this very early stage of planning, I don't want a 10 level deep schedule as an outline. I may only want down to level 3. So I can actually tell the computer, hey, you've got the right WBS structure, but I want you to roll it up to a summarized level. And that's exactly what that summarization level allows me to do. The net result, as you can see in the bottom screenshot here, is as a starting point, I've told the computer context, I've told it which level to build my outline structure. The computer automatically comes back then with that outline structure down to level 3. It's also coming back with associated deliverables and quantities based on those historical projects. So we can see number of permits is 30, modules 34, concrete cubic yards for construction foundations, so on and so forth. So immediately here, I'm starting to build my schedule with regards to quantities. Now, that's a much better way of planning, because I believe that one of the biggest variables in the execution of a project is quantity growth. And so if the plan is built upon quantities, that's a much better vehicle for adjusting the plan when those quantities change. So what we're doing here is we're doing two things. We're fast tracking the development of a top-down forecast, as you can see on the screen. And then secondly, we're benchmarking, because as we move forward now, what we're going to do, we're going to start to build out the schedule by adding activities and logic links, but we want to constantly benchmark back to this top-down schedule. So that's what these green indicators show in the Gantt chart. So when we get to the second level now, when we start to build out our activities, you'll notice that some of those elements now, they have activities within them, and some of those error warnings there are showing me that my detailed plan is actually breaching what I had in my top-down, my big picture estimate. Now, another massive accelerator with regards to plan development is the ability for the computer to make suggestions as to what the subnets should be. Subnets being more detailed chunks of work that are embedded in the schedule. So on the screen here, the cursor is selected design, and you can see under design there are 4 activities. Well, I, as the planner, I didn't even have to add those 4 activities: the proposal submission, reviews, permitting, and create early stage scope there. Those 4 activities actually came from the computer making suggestions. The computer understood that I'm in pre-construction design, and based on understanding context, it came back and made the suggestions, and then I adopted those suggestions into the plan. And I think one of the massive lessons that we've learned in the last 2 years is, as an expert planner, I am not very open to a computer telling me that this is the answer. Instead, I'm going to have more trust in a computer if it comes back with, hey, I've got 4 suggestions that I think you should consider, Dan. And not only that, I'm going to give you a degree of confidence that each of those 4 are correct. So on the right-hand side, you can see there's actually 1, 2, 3, 4, 5 suggestions that it's come back here. So these are 5 analogous areas of scope that the computer's saying, hey, on previous projects, Dan, this is how long the design scope took. The little colored segmented bar, you see the top one sort of fully colored, whereas the bottom one's only about 50% colored. What that's telling me is the confidence that the computer has that it's got the right answer. Well, that's great, because now I, the planner, still own the plan. It's not the computer saying, I'm going to take over and change your plan. I still have ultimate control, but I'm able to adopt the suggestions from the computer. And not only that, the computer's giving me a confidence as to how correct those suggestions are. Does that make sense? Yeah. And in addition to duration, the inference engine, the AI and the machine learning component of Basis comes back with not only durations, but also whether I have the correct logic, the inputs and the outputs, the predecessors and the successors. It also comes back with common risks that have occurred on previous projects, again, based on the fact that I'm working on, in this case, pre-construction design. So it's this all-encompassing, again, it's like having an expert guide sitting next to me as I'm building out my plan. Mm-hmm. I get to adopt and take into account what the expert is telling me, but if I choose to reject it, I still have that flexibility and control over the plan. Right. So the third step is, once we've established our top-down plan, we've then built it out using our CPM detailed scheduling techniques. That's all very well for planning, but when we get into execution, this is where we now need to break that very detailed big picture or longer term schedule into a much shorter look ahead. And typically that look ahead is order of magnitude 2 to 3 weeks. So as you can see on the screenshot at the bottom here, we're actually looking 2 weeks forward, and we're looking a couple of weeks back, so I can look back on not only what I've achieved, but also look forward on what I'm about to work on. And what's really great about this is I can start with my CPM schedule. So the 3 blue bars are the 3 activities that I, the foreman, have been assigned to. Now, as the foreman, it's my responsibility to do a couple of things. First of all, go off and assign a crew, and then those crews then are assigned daily steps. And it's those green and red daily buckets there, John, they are what we call those short interval steps. Now, in the kind of the old days or arguably current state, this is very often done on a whiteboard with Post-it notes or sticky notes, right? And you just stick the notes on the daily buckets. We're taking that to the next level. What we're saying is, well, okay, if I, the foreman, assign a crew, the computer knows how many people are in that crew, and if it knows how many hours per day that crew can work, if it then gets told the productivity rate, okay, well, hold on a minute. We know the productivity rates from our historical projects. So we know how many people, we know the productivity rate. if we then tell the computer, well, these are how many widgets we need to install or how many cubic yards of concrete we need to pour, the computer can actually calculate the number of hours and the number of days needed to do that short interval plan, that short-term plan, and that's exactly what this does. Now, where this becomes, I think, really powerful from a reporting perspective is in the first example, those green elements, they are adhering to, they are sitting within the blue bar. Well, remember the blue bar is the scheduled activity. Mm-hmm. So my short interval plan is able to uphold and adhere to the blue schedule activity. Well, the next two activities down, the short interval plan actually blows out beyond our scheduled activity. And even worse than that, the third activity, the work's actually not even sitting within the scheduled activity whatsoever. Right. So for the first time ever now, we have the flexibility of doing our short-term 2 to 3 week daily planning out in the field. Not only that, but we can capture status and actual progress on those daily steps, but then we can report those daily steps and compare them back to the big picture schedule. Well, why is that important? Well, it's important because in the case where we breach the schedule, the bottom two activities, wouldn't it be great if the computer then could update the schedule? And not only that, if that then gets recorded in the knowledge library so that the next time around, that template is more accurate, it's reflective of the fact that in reality in the field, we weren't able to achieve that, and it adjusts.
Next time we'll have more green under the blue.
In an ideal environment, you're marching towards all green ultimately, right? Yep. So that's the concept behind what we call short interval planning, and again, it's all incorporated into the CPM plan, which stems from the top-down estimate. So it's that three-step process. So going beyond just the concept of scheduling, what we're also doing now is introducing, as I mentioned, another dimension in the form of risk or confidence. So when you build a plan, you're really building, well, we call it a deterministic schedule. I think it's the best case scenario because you're not taking into account things like quantity growth and external risk events, whether it's weather or industrial relations causing a labor strike or a mechanical failure or an HSE incident, things like that. You don't add those into your schedule. So really when you're building your schedule, you're creating the best case scenario, not the most likely. Well, wouldn't it be great if you could actually understand what the most likely scenario is? And maybe even more importantly, let's look at some of the more pessimistic scenarios. Let's look at perhaps the worst case scenario. And even more importantly, what if we could look at the range of outcomes from best case to worst case? Well, that's what this aspect of risk actually allows us to do, because what happens in the tool is once I, the planner, have established my plan, I can invite team members, stakeholders, field executioners, discipline leads, people that understand and have knowledge of the project. I can invite them to vote and give input on the realism of my schedule. So in the top right-hand corner, we have an example here where we've got differing opinions. So I suggested the duration is 13 days. We've got 3 team members suggesting 20 days, 13, and 9 days. Well, those 3 differing opinions can then get thrown into the schedule as what we call uncertainty, and those opinions can be duration-based or quantity-based. And then the same thing can happen with risk events. So in the bottom right, we have a team member here that's identified 2 risk events. One is relating to a risk of first-of-kind design. The second is with regards to regulatory authority changes. And each of those risks carry both a probability as well as a schedule impact. So what happens is the computer then can take into account the impact of those uncertainties and the risk events. And as I'm toggling on and off the impact of the risk there, if we look at that design proposal submissions activity, without accounting for risk and uncertainty, the duration is 13 days. If we then account for that risk look, it massively pushes out to 161 days. And even worse than that, you can see the knock-on effect through the rest of the schedule. Remember at the beginning, we talked about the color coding to show the benchmarking. Well, now we have some orange or kind of the pink colored segments on submittals and approvals and early site work parking lot. What that's telling me is as a result of some of the delays caused by risk on design, we're going to have a schedule burst on the submittal approval and early site work, parking lot work. So for the first time now, we're getting in real time an insight into the potential impact, not only on our critical path, but on the project as a whole, as to how hurtful are those risk events going to be. Well, if we can see this and we understand the delta, which we can see, then we have an opportunity to mitigate those risks up front and get us back to the more optimistic forecast. So pretty powerful stuff.
And the computer learns from, we talked about the team buy-in and building confidence in the plan. Does the computer learn from the team buy-in and use that buy-in or no buy-in as knowledge for the next project down the line?
It does. So actually, you see the little, I call it a cell phone tower column on to the right of the Gantt chart, just about here.
Yep.
So what this cell phone tower indicator is reflecting is how much alignment do the team members have with me, the planner. And so that alignment, or very often misalignment or disagreement, also gets tracked by the knowledge library. So yeah, absolutely. So I think kind of wrapping it all up and tying it together. I think with regards to big picture, I think without a doubt, artificial intelligence and machine learning is changing the interaction between humans and computers. Again, as I mentioned in the introduction, historically, computers have absorbed information that we, the humans, type in typically through a keyboard. With AI and machine learning now, it's the computer's turn to actually start giving back and intelligently making suggestions back to the human. And I think what that means with regards to project management and planning is we are now at the point where planning is really knowledge driven rather than data driven. We're starting to take into account lessons learned, and we're able to leverage historical performance in a smart enough manner that warrants being able to take those lessons learned and that historical information and use it in our current plan. Realistically, some of the challenges, this isn't a magic bullet by any means. That there's some, with anything positive, there's always an overhead, right? And one of the challenges is, the system is only as smart as the information that it has to feed off. And so you do absolutely have to feed the knowledge library with historical projects or templates or subnets. And there's also, as we mentioned with the knowledge tags, tagging and decorating that data and converting it into knowledge so that the computer understands context, again, whether it's location or type of project, so on and so forth, absolutely does take some upfront effort. I believe, and from what we've seen with adoption, that upfront effort is massively it's minuscule compared to the benefit that you get if you spend the time actually doing that classification. This whole concept of the computer automatically adjusting its weighting is a genuine concern, and getting that bias, or we're making sure there is not unfair bias in those weightings. And really that's just a case of the more you use the software, the smarter it gets, the more accurate those weightings become. Now, on the positive side, the benefits, I think, I think they're self-explanatory. I mean, the fact that now we're not planning in isolation. I, as the planner, I'm not just relying on me. I'm relying on, or I'm validating from team members. I'm validating from all of that historical information, and it's all being funneled through my planning environment through the AI engine. And for those of you that are perhaps a little skeptical of technology, I would challenge and say, well, okay, I think it's pretty damn hard to argue that it's not better than the status quo that we have today with that 50-year-old legacy approach to the CPM approach, right? So, I think this is a really exciting pivotal point in the history of planning and scheduling. I think this whole concept of inference engines making suggestions, I think is incredibly powerful. I think the inference engines are going to get smarter and smarter over the coming years. And I think really we're at a point now where, and this isn't just pertaining to planning and scheduling, it's estimating and project controls as a whole, we're really now finally moving from very much an analog world into a world where we are digitizing all of these points of information, whether it's documents, cost estimates, risks, schedules, and by digitizing and classifying all that information, then the AI engine can go and mine and feed off that information. So very, very exciting times with regards to the technology enablement that AI brings to the world of planning and scheduling. And again, I think it's so needed. When you look at the success rate of large capital projects, it's pretty dismal. And I think erroneously we blame poor execution. Well, it's not execution. Think about it. When you embark on a project, you build the plan and then you execute to that plan. And if your execution falls behind the plan, the project's called a failure. Well, what if the plan was wrong in the first place, right? The execution might be as good as you can get it, but if the plan in the first case was too optimistic and aggressive, then that's where we need to focus on improving. And that's where I believe AI and machine learning is already having a massive influence.
We have time for some questions. We have a few. We have a couple. One that came earlier in your presentation, Dan, was does this factor any type of PERT analysis whilst determining durations?
So PERT analysis pertains to the science of risk analysis. So PERT actually stands for Program Evaluation Review Technique. There's two approaches to risk analysis. The PERT is a calculation. It's effectively a weighted average. So remember earlier I had the example where we had 3 team members contributing or pushing back on the durations. We actually use a PERT calculation for that. But there's a toggle in the tool where you can also run a Monte Carlo simulation as well. Both approaches have pros and cons. They both result in a risk-adjusted schedule.
Mike asks, how can I organize a demo based on my historical projects? I'd love to see this working in a real database.
I don't normally get asked that question, so I'm the lowly thought leader on this. Offline, we will absolutely reach out and, but yeah, I mean, loading in some, a handful of historical Microsoft Project Primavera schedules is very, very simple, and it will enable you to see the power of the AI inference engine.
Here's a question, is a cnumber.net helpful in machine learning? What are the technologies used basically in this type of development, I guess, InEight basis development?
So I think the question is regards to the technologies we're using for machine learning.
I believe so,
if
yes.
I understand the question correctly. So the product is actually a blend of what we call a knowledge-based system and a neural network. So the knowledge-based system is the knowledge library, and then a series of rules, and then the neural net is used for the matching. So that was a high-level answer to the question I think that was being asked.
Okay, I think that should be wrapping things up. We appreciate all the questions that came in. Sorry we couldn't get to all of them, but we had a few there that would have kept us here for a lot longer, and we don't have that type of, maybe the next time we can. So thank you, Dan, for that wonderful presentation. To learn more about InEight as well as our risk planning and scheduling solutions, visit InEight.com and click the Request a Demo button. And also mark your calendars. The next webinar in our risk planning and scheduling series is August 21st. The title, 100% Plan Complete, How Do I Get There? Thank you for watching today. This concludes our webinar.